Welcome to session 4 of To Be or Not to Be. That is the question for those interested in the compatibility of Christianity and science. And the topic today is geology. I always want to begin with a signpost because that is very important that we have the fundamentals right. We must recognize that people have different worldviews, and the worldview is what you see. Your values, your attitude, your behavior, your belief system comes out of your worldview. A second point is that there is such a thing as absolute truth, and it is unequivocal. In other words, there can only be one truth, whatever that may be, but there is only one. The other thing that I always hammer on is that nature is prescriptive and science is descriptive. There's a big difference. And then there is a thing called operational science, historical science, and forensic science. These are also three different things in terms of their process. Operational science, you remember, is the one where from observation we make an hypothesis, we do a lot of experimentation, and we come up with a theory. And if that theory can never be falsified, then that is a law of nature. And the purpose of the series of these 6 talks is really not to be a Bible study or to be an evangelistic outreach, but to provide a rational and reasonable argument or arguments for Christian apologetics. And apologetics means defense of, not apologies. Just that you know, it comes from the Greek word apologia, I think it is. To make you think, that is another purpose that we've got here. To make you think, to get better insight, and possibly get some wisdom with respect to why the world works like it does. I want you to see the bigger picture and then focus on some of the detail. The rules and the laws of life are given. We had no choice, but here we are now, and we have life. But is there ultimate meaning and ultimate purpose in your life and in my life? And all I want to really, under purpose, still add is that I want you to start thinking. Explore deeper. Okay, let's get going. Geology as a historical science, I put it on top this time because there isn't very much I can say about it. The history of geology, there were people like scriptural geologists. There's a person called Buckland in the 1820s who had certain ideas. There were the uniformitarians like Lyell in the mid-1800s and a couple of others, of course. And the development of the geologic column was put up, and it was put up in conjunction with fossils. So the fossils had to correlate with the strata, and the strata had to correlate with the fossils, which to me sounds a bit like circular reasoning. And then there is, of course, geology as an operational science in terms of rocks and minerals and the processes like oil drilling and mining, and even making cement and concrete technology, and geothermal energy and magnetism and tectonics. There is uniformitarian slow tectonics and catastrophic tectonics. There's earthquakes, which are pretty catastrophic, volcanoes, which can be very catastrophic. And of course, operational geology also looks at tunneling when we want to make a tunnel from Paarl to Worcester through the Toys Mountain, prospecting, earth interior and the hydrosphere, in other words, all the stuff that has to do with water in the atmosphere, and includes climate and glaciation and ice age and stuff like that. So there's a lot of operational science in geology, like also simulations and measurements of continental subduction and the origin of continental drift, a universal flood maybe, an ice age. And these are all supported by many parts of Genesis and Scripture. But it would appear that a lot of operational geology science is now coming up with very similar answers. So just as I mentioned already, mining, oil drilling, fracking, nuclear waste disposal, coastline protection, earth dams, tunnel building, canyon formation, Where's all the sediment? There's a lot of operational science in geology. If you look at caves and stalactites and stalagmites, the stalactites are the one that are growing downwards and the stalagmites are growing upwards. At least I hope I got that right. And of course, there are other examples of investigating the Grand Canyon and the volcano, Mount St. Helens, and possibly tree stumps. Tree stumps? Yes, you will see in a moment what I mean. But if we look the big picture of geology, then you look a surface pattern like this one, and you think, is that design or is that by chance? Well, this looks pretty much like by chance, right? We see folds, mountain folds there. We see a little bit of planation and so on. But let's see, if we just turn it by 180 degrees, look what we see, a human image. Is that chance? Is it design? Well, I would still say that that is probably a chance that it looked like this. In other words, just a chance thing. While this one is probably by design. It is very unlikely that erosion and tectonics or whatever had a role in producing these 4 American presidents. Is this by chance or by design? Well, it depends. If you go further out, you might see this, and then you will recognize it immediately and say to yourself, but a human being had to do this, or at least some intelligent being had to put this on the ground, right? Is this by chance or by design? Well, the left picture is most certainly made by man, while the left one looks as if it's a natural process that shaped these columns, right? By chance, by design? You see this on the beach? What do you know immediately? There was a human agent behind this. This is not a random chance thing, right? Let me show you as an example, because I should have said this at the beginning. The geology is such a wide field. I'm not trained as a geologist, but I have been reading up on it probably for the last 20 to 30 years, with, I admit, a rudimentary understanding, because I'm not trained in geology, but sometimes that has the advantage that I don't carry any of the baggage of paradigms that have been taught at university. But Mount St. Helens, which is situated just on the southern, almost the southern border of Washington State, on the border to Oregon, on the west coast, in other words, quite close to Portland, Oregon. And this eruption of this mountain, I was quite closely not associated with, but I've been there many times. I think I've been to Portland, Oregon 9 times, and I visited this mountain about 3 times, and once with my whole family. Before May the 6th, it looked like the picture on the right. It was almost, I speak under correction, but 3,000 meters high. And then it had a massive eruption, and after all the dust settled and so on, it looked like the picture on the right. Now, this happened in a couple of weeks. This did not take millions of years. You say, oh, well, obviously it's a volcano. That happens quickly. Yes, that's right. But what did we find? Once again, the issue also in geology, as it was in biology and cosmology, is not really the operational science side. That's quite clear. But it is about the unobserved past and very often about origin. And there's much evidence for catastrophism in the geological world even today, or maybe I should say especially today. The perspective of uniformitarian thinking has prevailed, however, mainly to support secondary philosophies. What you have already learned in the first 2 talks, actually in the second and the third one, Earth formed about 4.5 billion years ago by the accretion of the solar nebula, a disk-shaped mass of dust and gas left over from the formation of the sun, which also created the rest of the solar system, and Earth was one of those, initially molten due to extreme volcanism and possibly frequent collisions with other bodies. And geological time is given in millions and hundreds of millions of years as a result. Now, I asked you then in biology, and I asked you then in cosmology, and I ask you now again, is that factual? Is it measured? Has it been observed? No, it is invoked because surely it must be true. There is no other way. That is a story. Based on which paradigm? The paradigm that there is definitely nothing supernatural here, which is acceptable if that is the framework, but then you must have the greatness and the honesty to admit that that is what you have decided from the beginning. And if that is what you decided from the beginning, you cannot allow any supernatural effect in this. But the world is full of supernatural effects, but that's also another story. But much current scientific insight does not support many of these statements I highlighted in red up there. And yet they are still prevalent. You watch any National Geographic or history movie or anything like that on BBC, nature movies, you will hear these things over and over and over, sort of dished up as if it is the truth. That's the paradigm. We start off with the truth, now we must just find something to prove it. There were three paradigms in geology, and I'm not going to go into it very deeply. But it is important that you must know there were two guys, Hutton and Lyell, who in the mid-1800s actually provided the basis for geology. And they did not believe in a beginning or an end of the universe or even the earth. And the millions of years were introduced to make uniformitarianism plausible. And this became, of course, very helpful in the mid-1800s. Remember, that was also when Darwin came up with his idea, where the time requirement for evolution was also in the millions and millions of years. There were catastrophists who were in Buckland in the 1820s, in other words, preceding Hutton and Lyell. And they were actually, they still believed that there was a definite supernatural beginning of all this, but also millions of years ago. And at some stage, natural regional effects or global catastrophes destroyed most of life and produced major geological and geographic upheaval and produced new life forms. That's what they believed. And then there were the geologists that lived before 1820 who were called scriptural geologists. They were not necessarily trained in theology or geology for that matter, because those things weren't so separated in the 1800s, early 1800s. And they believed that God created the mature creation in 6 days, like Genesis says, and so on. They also believed that the unique year-long Noah's flood changed the earth's surface dramatically, wiping out all things except the occupants of the ark. So they were very biblical based, if we can put it like that for now. And then, of course, we have the earlier, even earlier Western scientists who accepted a scripture-based perspective and made that their axiom. They said, well, if the Bible is right, remember we're talking 15, 16, 1700, if it is right, then we look in nature for those rules that would be biblically supported. Maybe the wrong way around, but that is what they did. And so out of that came creationists like Francis Bacon, who is really the initiator of experimental science, Johann Kepler, who was, of course, an astronomer, Blaise Pascal, who is famous for air pressure measurements and stuff like that, Robert Boyle, Boyle's law, you might remember from your school physics, Isaac Newton, who produced a whole host of formulations that became known as laws. Carolus Linnaeus, I don't know exactly how to pronounce the man's name, he is Swedish, and he made it his task to classify all animals, and I think it was just animals, I'm not sure about the plants, but he worked out a system whereby you can categorize living beings. James Maxwell, who combined electricity and magnetism together, also very famous. The point I want to make is, those were what you would today call creationist scientists. But here were guys like that, also Lord Kelvin, and today there are many thousands. I know at least of about 80 to 90. Yes, 80 to 90. So in today's operational scientific insight, we find that some of the things we find out now actually fit Genesis pretty good, and other parts in the Old Testament. Again, as I said, my purpose is not to push that in your direction, but I want you to think. Don't just throw out the baby with the bathwater because the word Bible appears in it. That's very unscientific too. If we look at the big picture aspect, the big differences are the assumptions we make in the beginning, and that's based on your paradigm. We've already heard of two aspects here in geology: uniformitarian and catastrophic events, slow and gradual, in opposition to fast and violent. There is the conjecture of extremely slow geological processes, but they were not observed. Catastrophic events that were observed or can be inferred by direct measurements and simulations are treated with skepticism. That is very strange. That's very strange. All geologists are really taught to think this old thing that Lyell started: the present is the key to the past. So whatever you observe today, that is how it happened in the past. And that is the axiom for geology, really, sort of a basic truth, but it is not necessarily the truth, as every earthquake and volcanic eruption actually shows. And remember again, the main objective for this talk is to consider alternatives to the standard paradigm or dogma. Yes, even atheists have a dogma. I don't, in the end, want to stand there and say, I'm right and you're wrong. It's not about that. It's about thinking. It's about system thinking. It's to find out what is the truth with rational and reasonable thinking thrown in. There are three events that are really very much tied together: the global flood, an ice age, and a mass extinction. Can they be tied together? Well, indirectly, let me try and show you. The geologists of modern day are no longer happy with uniformitarian assumptions because they notice that periodic violent events may have changed the face of the earth much more than the slow and gradual events in the past, and that it didn't always take millions of years to show something up. Global cataclysms like Noah's flood, as described in Genesis, now look more likely to be true than skeptics could accommodate with uniformitarian thinking in the past. And during May 1980, Mount St. Helens erupted violently enough, and some of the downstream events of this eruption shaped the environment, the local environment of course, within a few days, and some effects in hours. This event wasn't a creative event, no, it was the opposite in a sense, but it showed clearly some mechanisms and processes which left its mark on operational geologists and other earth scientists. And an event such as Noah's flood would be so far out of course for our experience and our imagination that the geological and climatic conditions would be difficult to explain prior to the 1950s. But operational science, geologic science, has progressed very far over the last 60 years since plate tectonics was even just considered as an option. And an eruption of a volcano like Mount St. Helens could be observed closely by human eyeball, but also with a lot of scientific measurements and instruments, and by satellite and ground penetrating radar. Everything was measured up, scaled up, numerically simulated, and new conclusions could be drawn. That is operational science, right? But you might say to me, the flood was a hydraulic event and Mount St. Helens was a local volcanic eruption. Can the two be compared? Yes, they can, as I try and show you in a moment. They can be seen to act together, as the waters were primarily also released volcanically from the deep due to volcanic and tectonic action. The vertical tectonics and the interaction of the asthenosphere, which is that area above the mantle of the earth core, which is even underneath that, this asthenosphere is the place where the continents are actually swimming on, if I can put it like that. And then, of course, the interaction between the asthenosphere and the continents in the subduction zones explains a lot more today than we could 60 years ago. And also the rain that was released in copious amounts, unimaginable even by today's biggest hurricane downpours standards, if you like. Let's take another example, and we come back to Mount St. Helens. But look at the Grand Canyon. I've had the honor of having been there. Is this evidence of a global flood? Or is it a millions of years of slow erosion event that carved this massive, massive canyon over a length of I don't know how many decades of kilometers and millions of years, of course, and all done by that little river? Well, if you look at the flat surface in the background, you would see that a river would really have a bit of a problem, because if you look at the real heights today, the river is running in the wrong direction. But that's a minor, because there could still be vertical upliftments, and I'm just asking you, apply some systems thinking. Systems thinking is looking at the bigger picture, okay? And then you give attention to detail. So let's have a look at that. Here's another picture on the left of the Grand Canyon. Uniformitarian dogma says, or used to say, it is between 500 and 300 million years old. By 1869, some people, on the basis of measurements and so on that I'm not exactly aware of, they decided, no, it's not that old. It's about 70 million years. By the 1960s, when I read the first time about these things, it was downdated to about 5.5 million years. And now we're talking about 3 million years and 1.5 million years in the literature and journals that I occasionally read. Yes, as a layperson, not as a geologist, but I understand 70% of it. Hopefully the right 70%, okay? But what do I read there? That the latest estimates are now less than 600,000 years. Now, you know, I understand science progresses, but this thing is getting younger and younger and younger, and the uniformitarians and the evolutionists and the atheists are running out of time, because that couldn't have happened very easily in such a short time, right? This does not fit the theory anymore, because catastrophism has got answers for some of these things. So the question is really, a canyon like this, similar to the Fish River Canyon, are such canyons formed by a little water over a long period of time, or by a massive amount of water over a very short time period? You've all seen what a flood can do, what a local flood, how water can destroy things very, very quickly. So what does operational science say? Here's Mount St. Helens in May 1980. There it goes. That whole north face of the mountain plus the top actually slid away. 500 million cubic meters of it. That's what it looked like before, and that's what it looked like long after the eruption. You can even see some green there in the foreground on the otherwise very moon-like sort of area. The lake at the bottom there is Spirit Lake, which had always been there. Most of that landslide actually pushed into that lake and changed the environment completely near the lake and the shorelines of the lake. When I was there the first time, I was probably in 1995, somewhere there, or 99, can't remember exactly. But there were lots and lots of these broken trees, and there was a particular point where the trees were broken, and then further away, the trees were standing what to me looked like normal forests, okay? So in 1980, this explosion was not even counted as a very, very large volcanic eruption, not to say it was a small one. But all the wood you see floating there in Spirit Lake on the picture is millions and millions of tree trunks. In fact, after the eruption, straight after the eruption, almost that whole lake was covered in logs. And of course, because the force of the blast, most of these trees were without branches and without roots even. That was just shorn off. Okay, let's see where we go. Now, that soil and that pyroclastic flow and the blast itself created a canyon. And this canyon, just for comparison, there's a person standing there. The stratification that you also see in something like the Grand Canyon, but for different reasons, the stratification is evident. And the implications are there must have been very fast flow. Maybe it was calculated afterwards between 200 and 300 meters per second. The speed of sound, by the way, is 320 meters per second. So these are solids that are moving at an enormous speed, This is what it looks like downstream. This happened in a couple of hours. A couple of hours, this was carved out. If you look at this picture, which happened downstream, you can see the erosive power of that combination of water and pyroclastic flow. It planed off all the unevenness, and it also created the canyons that you can see there. And all this just took a couple of hours. It did not take millions of years. But you can see very similar features on the Grand Canyon. We are going to have a look at that closely just now. After the eruption of Mount St. Helens, there was, after the next couple of months, the growth of a new dome. And this dome cooled off in those couple of years from 1980 to 1996. And they took a sample of that cooled off lava, and they wanted to radiometrically date this with the potassium argon method. Now, potassium has got the symbol K, Kalium in German. I don't know why they used the German abbreviation there, and argon. But they did not tell the laboratory where the sample came from. They wanted an unbiased measurement of how old these rocks might be. And the potassium argon method measures the amount of argon atoms that presumably formed from the radioactive decay of potassium atoms in the lava after it cooled. So it's a very straightforward test of measuring, well, when I say straightforward, measuring the amount of argon atoms that were formed in that lava, but after it cooled. The rock was a mere 10 years old, but the potassium argon clock dated the rock at 350,000 years old. And the minerals within it were dated as up to 2.4 million years. Now that is obviously not correct, which shows you there are many assumptions made with radiometric measurements. So it's a whole story on its own, but it is just something to remember. So if we look at an aerial view of the Grand Canyon, or a part of it, just a part of it, we see something very similar. And we see planation. In other words, the top layer is as flat as a pancake. And then we see these severe erosions. Now you could imagine that a massive flood with lots of water, lots, I mean as in a kilometer or two high, all right, flowing over the land, planating whatever hill or mountain was in the way, laying down sediment after sediment after sediment. And there are all these layers here on the right in the picture that you can see. And then as the water recedes and runs into the sea, you would still have enough powerful water flowing down into gullies and excavating them massively, just like it did at Mount St. Helens. Oh, the debate is now, how old is this actually? But you see, it once again depends on your worldview. and your perspective. If you have the perspective that this was a little trickle of water over millions of years, okay. But if you have the perspective this was a lot of water that ran across this area and excavated then the canyons of the Grand Canyon. So we get a beautiful layering here that you can see on this picture. You see how flat it is at the top, and then you have all these sedimentary deposits, and then when the runoff of the water occurred, then you get all these valleys. Okay, back to Mount St. Helens. Spirit Lake is that lake at the bottom there that had all those tree trunks that were collected in it after the eruption of Mount St. Helens. Now we do see petrified tree stumps in many places. And here's the vexing thing. This tree there on the left is millions of years old. Why? Because all these straight layers, the sedimentation, you can see it in the picture, imply that that tree stood there for millions of years. Millions of years. If these sediments were put down in different time frames. But a tree doesn't survive even 1,000,000 years. So what happened here? What happened here? How did this tree get buried in various levels of sediments, which each one took a couple of million years, according to uniformitarian theory? And there are these forests in the United States that indicate, oh, there must have been forests here that petrified under different layers of sediment, and then water washed it away or whatever, and that is why they look the way they do today. Well, it's interesting that Mount St. Helens Spirit Lake had exactly the same effect. There were about 90 meters of height difference before and after the eruption in the lake floor, and many of those trees, actually those that swam vertically, some of them sank and got buried in the sediment at the bottom, and that sediment consisted of rocks and sand and branches and, of course, vegetarian material that was blown away by the eruption, and these tree stumps swam in the water. It looked a bit like this. So the universities from the state of Washington and Oregon went to these places, dived down into the lake to see what it looks like down there. And they saw, through the murkiness of the water, virtually the same effect that you have with the petrified trees in other locations in the United States and other places. What I wanted to show here is just that these petrified trees were not forests that were overcome by sediments and then new forests arose and they were overcome by sediments. No, there were catastrophic events that caused these trees to sink into the sediment of a lake, and they stayed there for many years. Remember, Mount St. Helens, the eruption is only 40 years old. So we can observe events that took only 40 years so far, and already we see the beginnings of these petrified forests. We see something else. The floor has now become peat, real peat. It looks like peat, and peat turns into coal. And we're already 40 years down the road, and we can recognize the peat and that it might become coal waiting long enough. But we're not talking millions of years. In fact, we can make peat and coal in a couple of decades. Yes, we can. You must just investigate it. Remember, I'm giving you facts, but you must follow it up, think about it, and see if it is reasonable and rational, what I'm saying. Here's another one of these forests. You can see to the left and to the right of this person standing there that there are petrified trees, but you can see in between there are layers of sediment, which again, according to uniformitarian theory, have been laid down over millions of years. Well, those trees did not last millions of years in those positions, that's for sure. So think about it. It's called polystrate vertical trees. In other words, they run right through a couple of strata, which are layers of sediment, which traditionally took millions of years to get there. Here's another interesting one, Devil's Tower in Wyoming. Devil's Tower is the remnant of a volcanic core, and what we can see from the aerial picture is the easiest way to explain this: if a lot of water had flown across this plain, and you can see the planation in the background, and you can also see that the stump has all the soil and sediment removed from it around it. But the hard core, kimberlite sort of core, has remained standing. How did it get flushed away? It must have been quite a flood, because this thing is about 1,200 meters high, I think it was. And the volcanic cone, interestingly enough, although it is massive and impressive, it is now being eroded very fast. So it shows you that that core even wouldn't be standing there for millions of years, because it would have disappeared already. It would have just eroded away. So it is very unlikely that this thing is millions of years old. There are just some conclusions. Upright trees embedded in Spirit Lake bottom and covered in part with sediment is a very, very important indicator that things can happen very, very fast. Substantial peat formation, as I already mentioned, from the bark and branches at the bottom of the lake took only about 30 years. And that's a precursor of coal beds. The canyons that we saw earlier on, these canyons were produced in a few hours instead of thousands of years. And the largest landslide ever observed by mankind, where there were people watching it, was when a third of the mountain of Mount St. Helens slid into Spirit Lake and caused a devastating wave there. It is estimated to have been 240 meters high, which slammed into the opposite slope and eradicated all the trees, and whatever was living there, it's just gone. And that's why we know it was about 240 meters high. And this was followed then by molten rock and massive amounts of superheated steam to an energy level equivalent of about, they say, 10 Hiroshima bombs, nuclear bombs, okay? 20 million tons of TNT traveling downhill at 300 meters per second. We have quite a bit of force there. Rocks collected after the lava of the newly formed dome was dated as 350,000 years old, when it was in fact 10 years old. Rapid soil and vegetation recovery was also something amazing in the Mount St. Helens environment, because nothing grows in ash. But what is so interesting is that bacteria and a specific type of flower, the lupine, and gophers, a type of mole, actually aerated and introduced nitrogen in these last 40 years, that today you've got vegetation in all those devastated areas already. And of course the animals also come back. And you see, for me personally, because I've been there a few times and I flew over it, this event made a very big impression. I flew over it 15 years after the event. Yes, that's quite a long time ago, but you could still see the devastation very clearly. An impressive scene, although the eruption was a rather small energy affair. What I saw made me actually doubt the millions of years scenario that is always propagated. Even the notices at the petrified forests, they tell you it's millions of years. Unashamedly, it's never been proven. The dating isn't reliable. So if you query that, you get into trouble. And life is really back. This is about 35 years later. You can see the bottom picture is the original, and today there is greenery everywhere. Now there are three events that are very much tied together in this catastrophic plate tectonics. Secular science and Genesis actually agree that there was one big landmass initially that split up. The question is, was it a slow breakup or a fast breakup? Fact number 1 is land mass is less dense, because it's granite, than the ocean floor, which is basalt. And it floats on the lithosphere and the asthenosphere like an iceberg. That's fact number 1. Fact number 2 is the mid-ocean ridges produce new basalt lava material all the time that pushes the two sides apart. And an ocean is actually being created that way. All right, it starts small, it gets bigger. I'll show you a picture in a moment. Fact 3 is the subduction zones that you get off the coast of California, amongst other places, produce a ring of fire. That means, as on the picture indicated there, that a row of volcanoes exist just there where the slab runs underneath the continental landmass. And the stress in the subduction plate makes the rock more slippery and colder, or it is colder, but it heats up there, but it now has an accelerated movement into the magna of the earth. And that is all measured today. And it is operational science. It is important for you to understand that we have a spreading mid-Atlantic ridge, mid-Pacific ridge, wherever these ridges are. You get the ring of fire volcanoes just maybe 90 kilometers inwards from the coast. And in the subduction zone, these slabs move down and they now mix with the magna down there. You know that today we can measure some of that operationally, as I said. And here is a picture of how the oceans have formed. That you have some of the magna that rises up. It comes through these cracks. It pushes the land masses, you could say, apart. Water runs in. And eventually you have a continent on the left and on the right. But you have a lot of water in the middle. But the important point is that rift in the middle. Because if that hot lava comes out, and we've seen many underwater pictures of individual, I think they call them smokers, where this lava comes into contact with the seawater and it produces superheated steam. And it may be kilometers below the sea level. But, and this is my next point here, if, it is if, yeah, but it's a very likely possibility that if those rifts suddenly come up over a whole length of ocean, then you don't just have a smoker where some lava gets comes out and superheats the ocean. You would have a whole string of it, almost like a linear line, okay? And the mid-ocean ridges open on their entire length, and that produces massive superheated steam vents, which heat the ocean water, that's number 1, and expel masses of water into the atmosphere. And this comes down again when the whole atmosphere is covered now in humidity, clouds, and so on, because it's the whole ocean now, remember? And all that water gets blown into the atmosphere. Now it comes down as a deluge, a massive, massive, massive rainstorm, which probably will be measured in meters, not in millimeters. Okay, number 2. The land mass is now temporarily pulled under sea level. How can that happen? Well, the tectonic plate pushes down and it draws the continental landmass with it down, so they will be underwater. But after a while, the buoyancy of the landmass comes up again. You've seen all these things on a piece of wood, or even if you take a big piece, say a brick, and you throw it in a swimming pool, it makes a visible hole for a very short time. But if you had something like a piece of wood next to it, it would actually be drawn in if it is close enough and then pop up again, okay? Now, the subduction slab can move up to 2 meters a second. 2 meters a second. That's really fast. It's called runaway subduction, and that could happen in a catastrophic event. laboratory experiments on rock viscosity under different temperature conditions, plus numerical simulations, finite element simulations, and as well as physical evidence on such rocks, such as that picture shows there, this narrow band of a very specific type of rock, prove that this was all possible. Very likely, in fact. And through this process, the continents themselves are also accelerated and move horizontally at enormous speeds. We're talking now also meters per second. The other effect of this is the Earth cools off due to the extensive cloud cover and massive humidity in the air. Do you know that those are the only real conditions to get an ice age going? Glaciation and partial ice cover results, and it could turn into an ice age. But it doesn't happen often. But it is quite plausible that these rifts opened up and threw all this humidity into the air, which then can cause an ice age. So, as I said, to get an ice age going, you need considerable and consistent cooling off in summer in terms of temperature and massive moisture content in the atmosphere. And this you can never achieve with uniformitarian processes. That's the big thing. That makes the one more probable than the other. One last thing that still has to do with catastrophic plate tectonics is there are lots of examples that corroborate all this. Normal erosion effect per 5,000 years has been measured, roughly, but there you are, for different terrains, different climates. It lies between 2.1 meters on the mountains and 6 centimeters in the Arctic due to ice. If the flood did, and I mean Noah's flood, the biblical flood, did indeed occur, we should still see the effects of the run of water. Indeed we do. There's planation. If you look at the Karoo from the aeroplane or from the ground, you see that the Karoo mountains are usually flat-topped, and there's even Table Mountain. But can you imagine how much water it required to flatten a mountain like Table Mountain and to erode all the sedimentary stuff that is around it? Well, where did all that stuff go? Well, it went into the sea, and the evidence is there today. Today we can measure the sediment layers off the continental shelf, and it correlates very much with the calculations that were made how much stuff had to end up in the sea to be able to give us so much sediment there. There are islands that were sticking out of the sea. They were, let's say, volcanoes. And when all this catastrophic tectonic stuff happened, these mountains were cut off by the sea, erosion, and then the sea bottom sank. And the mountains on the continents rose up. Can all be explained with catastrophic plate tectonics. Read it up. Find out more about it. In these 40 minutes, I cannot go into much depth on all this. You will see a lot of these submarine guyots in mid-ocean. You don't see them from the top because they are submerged, but there are sometimes up to 2 kilometers between the flat top and the sea level. That means that is so much. Actually, the sea floor has actually dropped down. And that's amazing. Now, I know this sounds almost incredible to you. You must read up on it. There's ample evidence that the sea subsided globally by thousands of meters. Unimaginable. But it is so. The evidence is still there. Such vertical movements have occurred always in a particular pattern. And the pattern is land goes up and the seafloor goes down. And there's considerable evidence also of this huge erosion of the continents, as I mentioned already. The mountains and the plains have also telltale signs of fast-flowing sheets of water, which were themselves kilometers high.
And this erosion occurred very rapidly, very, very rapidly. Devil's Towers is one example. There are many of those. Devil's Tower has also been truncated, as you notice. It's not a sort of a sharp point there. It's truncated at a certain height. It was probably buried under a lot of sediment and then flushed away by the water until all the sediment had flushed away and the hard core, volcanic core, was still remaining. But now it is eroding very fast. It will not stand there for millions of years. It'll disappear much, much faster if we take the erosion rates today. So where did the kilometer high erosion products from the strong water flow go to? They went into the sea. And as I said already, the evidence is there, we can check it out. And you also get a lot of sedimentary stuff high up in the mountains, like the Himalayas and the Andes. And you know, that yellow part in this picture can also be kilometers deep. Kilometers. So, I've said a lot of things. Again, two things you have to do. If you're interested in geology, follow up these things, study them up, have a look. I tell you what, there are more opinions than facts, even in geology, as it was in cosmology, as it was in biology, especially the historical science part. Remember, operational science and historical science. So the big thing is there are always more questions than there are answers. But why don't you explore it yourself a bit more? Explore deeper. Thank you very much.